Okay, guys, we are going to work a couple of more examples with logarithms and natural logarithms. When you first see this example, it's a little overwhelming because you have the natural log of a product rule and a square root or radical in the denominator. So that means quotient rule and chain rule along with the logarithm. But remember, and we have worked these types of problems before, what we want to do before we do anything else is we want to actually rewrite this to be an expanded logarithm. So the very first thing that we're going to do is rewrite this as the natural log of x plus the natural log of x squared plus 1 minus the natural log of, and I'm going to write this as a fractional exponent, 2x cubed minus 1 to the 1/2 power. So this is back to pre-cal concepts where we have to expand the logarithms, and then we're going to take the derivative of each of those. So if we start with the very first one, the natural log of x is obviously just going to be 1 over x. The second one, we can use u substitution. So we're going to allow u to equal x squared plus 1 and u prime to equal 2x plus 0, and we'll have that as an understood plus 0. So whenever I put my second term, the derivative of the natural log of u, as a reminder, is u prime over u. So we will write that as 2x over x squared plus 1 minus. And then the other thing that I want you to look at here is this very last term. This feeds exactly into example number 4, where we can actually rewrite this fractional exponent as a coefficient. And that's exactly what we want to do. We want to take this 1/2, move it out front, and then we're going to allow u to equal 2x cubed minus 1 and u prime to equal 6x squared. So whenever we take the derivative of that, it would be 1/2 times 6x squared over 2x cubed minus 1. From here, we're going to simplify. So this gives me 1 over x. There's nothing I can really do with that. This would be 2x over x squared plus 1. Minus, I can cross cancel here. 2 will go into 6 3 times. So I have 3x squared over 2x cubed minus 1. And that whole thing is actually going to be your answer. You do not have to worry about finding a common denominator. If it were multiple choice, then that would be a different story. You would need to recognize multiple facets of this. But in this term, this would be considered completely simplified. So that would be the end of this problem.